A warm greetings to one and all. In this session, let's learn about predicate logic.
Predicate logic is also known as first order logic. It is more expressive than propositional logic. It helps in knowledge representation and reasoning. It allows to represent and reason about the complex environment using objects and their relationships. While propositional logic deals with simple true or false statement, predicate logic can describe in detailed scenarios. For example, all birds can fly. Sparrow is a bird. Therefore, sparrow can fly. So this is how we represent the predicate logic. Let's learn about syntax and semantic of predicate logic. Let's start with sentence type. The first comes atomic sentence. Atomic sentence is a single predicate or a comparison using equivalent to. For example, predicate of term or term is equivalent to term. So for example, predicate is represented as eats of Tom, pizza. This implies that Tom eats pizza. Next example is term is equal to term. Here, height of Tom is equal to 180. This implies that Tom's height is 180 centimeter. Now let's learn about complex sentence. It is formed using logical operators or quantifiers. First comes parenthesis. Parenthesis is used for grouping the sentences. Next, negation. If yes is a sentence, then negation yes is not a sentence. Next, conjunction. Sentence 1 and sentence 2. Here, and symbol represents the conjunction. It represents that both the sentences are true. Next, disjunction. Sentence 1 or sentence 2. Here, the R symbol represents the disjunction. It represents that at least one sentence is true. Next, implication. Sentence 1 implies sentence 2. This represents that if one sentence is true, the other follows. Next, biconditional. Sentence 1 biconditional sentence 2. This represents that both the sentences are equivalent. Now let's consider the example for complex sentence. For negation, negate sleep of Tom. This represents that Tom is not sleeping. For conjunction, reads of Sarah, book and writes of Sarah, notes. This represents that Sarah reads a book and writes notes. Next for disjunction, rainy or sunny. R represents disjunction. So the sentence represents that it is either rainy or sunny. Next, implication. Studies of Jim implies passes exam. This represents that if Jim studies, he will pass the exam. Next, biconditional. Has a license of Anna, biconditional can drive of Anna. It represents that Anna can drive if and only if she has a license. Now let's learn about predicate functions and terms. Predicate represents a statement or relationship that can be either true or false. Function represents the relationship using the terms. Constant represents the fixed entities. Variable represents the objects. Let's have an example for predicate functions and terms. So the first comes predicate. The example is father of Mike, Helen. This represents that Mike is father of Helen. So this specifies the relationship. This can be either true or false. The next comes function. Father of Mike. This implies that Mike's father. Here, father is a function and Mike is a constant. So this function returns the value of Mike's father. Next, Mike and Helen both are constants which we are used in this predicate logic. The variables can be as x, y, and z and so on. The operator precedence from highest to lowest is negation, equivalent to, and or implication and by condition. So negation has highest operator precedence value and by condition has lowest operator precedence value. Now let's learn about quantifiers. The first comes universal quantifiers for all. The syntax is for all of x p, where p is the logical expressions. For all of x is called universal quantifiers and p is a scope of quantifiers. The x is said to be bounded by the scope of quantifiers. Let's have an example for universal quantifier. For all of x, dog of x implies barks of x. It represents that all dogs bark. Next, let's learn about existential quantifier, that is, there exists. This indicates that p is true for at least one value, that is, there exists. The syntax is there exists p where p is a logical expression. Let's have an example. There exists an x such that x is kind. It implies that some people are kind. So hope you are clear in quantifiers. Now let's learn about instance representation and easier relationship. Easier and instance are essential concepts in knowledge representation. They exhibit inheritance properties. Let's have an example. Shyam is an engineer. All engineers are intelligent. Here, engineer and intelligent are considered as classes. Easier relationship represents class inclusion. Easier of engineer, intelligence represents that engineer class is a subset of intelligent class. Instant relationship represents that membership of an object to a class. That is, instance of Shyam, engineer represents Shyam is a member of engineer class. Now let's learn about the difference between propositional logic and predicate logic. Let's consider the aspect definition. The definition of propositional logic is it deals with simple declarative statements, whereas predicate logic deals with statements involving objects and relationships. The next aspect is expression. It uses propositions, whereas predicate logic uses predicates with variables. With respect to complexity, propositional logic is simpler for basic reasoning, where predicate logic is more expressive for complex scenarios. With respect to variables, there is no variables in propositional logic, only true or false statements is available. In the case of predicate logic, it uses variables to represent objects. The next aspect is quantifiers. Propositional logic does not use quantifiers, whereas the predicate logic uses the quantifiers like for all and there exist. Example for propositional logic is it is raining can be represented as P, whereas in predicate logic, all dogs bark is represented as for all of x, dog of x implies barks of x. The scope of reasoning for propositional logic is it is limited to specific facts, whereas in the case of predicate logic, it can represent general rules and relationships.
Thank you all.